We can send in the paper at any time, right?
Yep.
Right. Typed or written?
Right. Okay. And remember, we do have the writing center over in Loretto Hall during, I think it's during Flex. So you can, you know, if you want somebody else to look at your paper before you turn it in, we've got kids over there that can do that for you. All right, we're gonna do some sketching now. We're gonna sketch one of each, a sine, a cosine, and a tangent. You've been at this long enough. What is your test going to look like? This, right? So if we're practicing this on the practice test, we know we're going to have to be able to do this on our test. So I see a cosine, so I'm going to sketch a cosine. Now when you sketch your cosine, I want you to look at what's on your paper and I want you to look at what's up here on the board, because this is the way a cosine should look. Some of you are kind of close, but I tried to make corrections on your quizzes so that you could see where you're going wrong. Cosines are the hardest because the shape is just broken. It just doesn't look right. You put a hash mark where you cross, the low point where you cross, and the end. Those are your hash marks. Okay. What are these? They're supposed to be 1 and -1, but because of the 2/3, they're going to be 2/3 and -2/3. So our amplitude is 2/3. Now these are supposed to be 90, 180, 270, and 360. That's what they're supposed to be. But what have we done? We've divided by a 4th. All these get divided by a 4th. So 90 divided by a 4th would be 90 times 4/1. So this mark is actually 360, 90 times 4. Now we can do the same thing with all of these. Multiply them all by 4. Or we could just keep adding 360. So 360 would be 720, 1080. I'm just adding 360, 1440. So my period is 1,440 degrees. Amuna?
I'm confused, but I'm just trying to clarify, why did you do -2/3?
Because this goes up 2/3 and it goes down 2/3. Okay, now we've got our tangent curve. So tangents, we already talked about one of these a minute ago. Tangents squiggle up through the origin. What's the amplitude of a tangent? Naught, right? No ceiling, no top, no height. And look, what does the fact that there's no number on that X mean? The labels haven't changed. So these labels are supposed to be -90 to 90, and they are still -90 to 90. Because the only way you can change the horizontal is by dividing by this number, right? Well, that number's a 1. Dividing by 1 doesn't change anything, so it stays just the normal labels. Okay? On your quiz, some of you missed that, didn't pay attention to that guy. What does that do, that negative? Flips it upside down. So whereas a regular sine curve would look like this, An upside down one is going to look like that. And what will be my amplitude here? 3. So 3 and -3 on my amplitude, or on my vertical axis. For the sine, I label where it crosses and ends, of course, and then the low point and high point. Those are supposed to be 90, 180, 270, 360. That's what they're supposed to be. But now I put a number in there, right? That divides. So I'm going to divide this by 2/3. I'm not going to freak out. 90 divided by 2/3 is 90 times 3/2. So 90 times 3 is 270. Divided by 2 is 135. So this label is 135. Could I do the same thing with the 180? Yeah. But I can also just keep adding 135 if that's easier for you. Doesn't make any difference. You're either going to do the division again, or you're going to add 135. So if I add 135, that would be 270, 405, 540. Is that right? I think so.
Yeah.
So my period is 540. Okay? Ramona?
Why is the white do that? Why is it 180? Aren't you multiplying the negative on the quantity before it?
How far is it from -90 to +90?
Okay.
Right? Have you watched the videos from when you were absent, Ramona?
No.
Okay, you need to do that, sweetie. Okay? Because that'll clear up, okay? Because there's a whole video where we just graphed about a billion things. Okay? Alright. So now we're ready to get our calculators out. Remember, this test is in 2 distinct pieces, and you'll get one piece at a time. You'll get a white page, that's what we just finished, and then you'll get a colored page that you will use your calculator on. Okay? You get them separately. So now we're going to do everything from here on is with the calculator. So the first thing says we have 18.775, and we want to convert that to degrees, minutes, seconds. Well, we haven't really done that since the day we talked about it in our notes. So we'll just remind ourselves, we type in 18.775, and then we go to our angle menu, and where is your angle menu? Second apps. And if you go down to number 4, it says DMS, which gives you degrees, minutes, seconds. So it's 18 degrees, 46 minutes, and 30 seconds. So we just go down to DMS, press enter a couple times, and it gives us our degrees, minutes, seconds. Okay, so how do we get degrees, minutes, seconds? We go into our angle menu and press the DMS button. Degrees, minutes, seconds. All right, now we've got a bunch of when we did these before, when we did these before, do you remember the advice I gave you?
Do all of one.
Do all of one kind, right?
Great.
So it doesn't really matter what you start with. It doesn't matter what you start with, but do all of one kind. So for example, you notice that this one and all of these have degree symbols in them. So let's go ahead and make sure our calculator's in degrees. And then let's just start typing these in. So we're going to do all the ones with the arrows first because they all have degree marks. So here we go. Sine 2814. So sine 28, second angle degrees, 14 second angle minutes. How am I rounding? 10,000. How many decimal places is 10,000? 4. So 0.4731. Is that what you got? All right, now we're coming over here. Secant 19. How do I put a secant into my calculator? 1 divided by cosine. That's the only way. Please don't do anything different. Secant is 1 divided by cosine. So 1 divided by cosine 19. And that is 1.0576. It's 1 divided by cosine 19. That's it. That goes all the way back to press. 1 divided by cosine 19. And then cosine 98, that's just cosine 98. So negative 0.1392. How do we do cosecant? 1 divided by sine. So we'll do 1 divided by sine, and then 15 second angle degrees, 19 second angle minutes, and 11 alpha plus, enter. So I got 3.7849. Are we okay with all that? Those are, all the degrees are done. Okay, so now we'll go to mode and change our calculator into radians. And then we're going to type tan 1.15. That's easy, just type tan 1.15. And it's 2.2345. And then second cosine 0.376, 1.1853. Okay, everybody got that? Okay. So now we've got some just regular little triangles drawn, and we're going to find some missing parts. So these are kind of like the word problems, except, well, the picture's different, but the picture's already there. You don't have to create your own picture. You just have to come up with an equation. So you have to look at this situation, and you have to come up with an equation. And the equation you come up with is either going to be sine, cosine, or tangent. So here's the angle. This is the angle, right? Oh, by the way, notice, see that? I better go back to my calculator and change back into degrees. Right? Okay, so I'm in degrees now, so I'm ready to go. But I need to come up with an equation. So relative to that angle, Which side is this? Opposite, adjacent, or hypotenuse? This is adjacent. This is right next to it, right? What's this one? Hypotenuse. So sine, cosine, or tangent, given that information. Cosine. So I'm going to say cosine x equals 11 over 14. Now, what do I type into my calculator? Be careful. The angle is the variable, so I need to do second cosine 11/14. Remember, when x is the angle, you have to use your special buttons. It's the only time you use them, but that's when you use them. Doesn't say how to round. All right, did you get 38.21 degrees? I'll just round off to the nearest hundred. Is that what you got?
Yeah.
That's your angle. Every time you write an equation to solve here, you're going to write a sine, cosine, or tangent equation. And it's going to depend totally on which sides you have relative to your angle.
And you said we always use the special button to tell it.
If x is the angle.
If x is the angle.
Yeah, we won't be using the special button over here.
Okay.
But here we do because the angle is unknown. All right, so what about this one? All right, here's your angle this time. So which side is this? Opposite. Which side is this? Adjacent. So what function, sine, cosine, tangent, are you going to use? Tangent. So tan 28. Remember, when you write tan, you must attach the angle. So it's tan 28. Or when you write cosine, you must attach the angle. So it's cosine x. Those go together. And then it equals the fraction, which is opposite over adjacent. Right? Now what? Multiply by x. So x tan 28 equals 13. And then what will I type into my calculator? 13 divided by tan 28. I have to get x by itself, so I'm going to divide by tan 28. So 13 divided by tan 28. I got 24.45. And in a word problem, I would have to say feet or something like that. All right, got it? Will Browning, you with us? All right. So now here's my compass. I've got it set up for you just beautifully. And you're going to draw a course of 118 degrees. What do you have to remember? It's different than normal. 0 is straight up. North is 0. Right? And then we go that way. So here's 90 and here's 180. And I am graphing 118. Wouldn't it look like this? That's what you draw. Full credit, that picture.
We don't have to do
You don't have to do anything. Nope, it's not here. Right? I'm doing the question that's asked. It is simple. But you have to remember that you start up here this time. Okay, now we've got a problem that we're going to do 2 different ways. So we're going to do it exact, and that means no calculator. Exact means no calculator. And then we're going to do it in decimal form. That means with the calculator. All right, so let's do that first. The problem is sine and cosine. All right, so let's do this first on the calculator with the decimal. You just type that in. Just type it in. You don't need to do anything except press those buttons. So you'll just press sine, second tangent, 2 divided by 5. And you will get your answer, which is 0.3714. Just press those buttons exactly. You don't need parentheses, you don't need equals, you don't need anything. You press sine, second tangent, 2 divided by 5. And this is what you get. Okay? Now we're going to do it exactly. That means without the calculator. So, these are the kind where we draw a picture of that. What quadrant am I going to draw that in? 1. Remember, if I want you to draw it in a different quadrant, I will give you information. So the tangent is 2/5. Opposite over adjacent. What do I have to do now? Hypotenuse. Using the Pythagorean theorem, what do you come up with? Root 29. So there's the picture of that parentheses. Now what do I want to know? The sign. So looking at that picture, the sign, here's your angle. The sign would be 2 over root 29 or 2 root 29 over 29. Now just for fun, would you type in on your calculator 2 divided by the square root of 29? Just type 2 divided by the square root of 29. What happens? You get that decimal, right? Sure you did. So on your test, you will have to do this problem just by typing it in, which is so simple, and then by drawing a picture of the parentheses, and then finding whatever you do. All right, and then the whole last page, at least on this practice test, is word problems. So here we go. I'm going to go ahead and set a couple of them up. This is the way they look. Right? So here we go, problem A. A squirrel is sitting in the top of a tree that's 76 feet tall. Does that make sense to you? He's looking at a note on the ground. His angle of depression is 37.8. What do I remember about that? It goes right here. Find the distance from the nut to the base of the tree. Where does X go? On the bottom. There's the nut, there's the base of the tree. Right? Now we write an equation. It's going to be sine, cosine, or tangent. Just figure out which one it is. What's it going to be? Tangent. Why is it going to be tangent? Because we're doing opposite over adjacent, right? The hypotenuse isn't involved. So we're going to use sine or cosine because we need the hypotenuse because we use sine and cosine. All right, how do I solve this? X tan 37.8 equals 76.
76 divided
Now, yep, whip out my calculator, type this in. I think I'm set in degrees. I want to make sure. Yep. So 76 divided by tan 37.8. I got 97, does it say that around? 197.98. And Solomon? right, next. A seagull on top of a lighthouse spots a fish in the water below. The gull is 78 feet above sea level, and he is 320 feet from the fish. Where's that 320 go?
Top.
The seagull is 320 feet from the fish.
Top.
Isn't it the hypotenuse? Here's the gull, here's the fish. They're 320 feet apart. Find the angle of depression from the gull to the fish. This is x. So I got to write an equation first, but because x is the angle, I'm going to eventually use my special buttons, but first I have to write the equation. So what's the equation going to be? Sine, cosine, or tangent? Sine x equals 78 over 320. Opposite over hypotenuse. And I will then do second sine. Anytime x is the angle, you're going to have to do second something. 14.11 degrees. C. How far is an airplane from the airport if he is 6543 above the ground and the angle of depression is 23? Did I get all my numbers in the right spots? Now where's the X? How far is the plane from the port? Hypotenuse. Equation? Sine. Sine 23. Remember, the angle always goes with the sine, or tangent, or whatever. So sine 23 equals 6543 over x. So to solve it, we will bring the x over and divide. Will I use my special button this time? Nope. Only need it if you're looking for the angle. We have the angle. So 6543 divided by sine 23. I got 16,745.53 feet. Anybody have a question about that? That seem okay? Two more. What do we got this time? We got a flagpole. It's making a shadow 31 feet long when the angle of the sun is 23 degrees. So we got 29 degrees, sorry, 29 degrees. And we want to find the height of a flagpole. Then the shadow is 31 feet. Where does that go? On the bottom, on the ground. Shadows are on the ground. Does that picture make sense to everybody? Find the height of the flagpole. All right, sine, cosine, or tangent? Tangent. Tan 29 equals x over, I can't read my own writing, 31. opposite over adjacent. If you don't have the hypotenuse labeled, it has to be tangent, right? Because everything else uses the hypotenuse. So 31 tan 29. I got 17.18 feet. You okay with that? What is the angle of elevation of a man looking at the top of a building that is 84 feet tall if he is standing 1, 2, 3, 4 feet from it? Where does the 1, 2, 3, 4 go? The man is standing on the ground away from the building. Where does the 1, 2, 3, 4 go?
On the bottom.
On the bottom. This is the distance from the man to the building. Sine, cosine, or tangent? That's going to be a tangent, but this time it's going to be tan x, right?
Yeah.
Which means I'm ultimately going to be doing my second tangent thing. So tan x equals 84 over 1, 2, 3, 4. So that is what I am going to second tangent. .89 degrees. Okay. All good with that? Well, guess what? We have practice test 2. So here we go. Now, we did this yesterday. Hopefully some of it is fresh in your mind. Let's see if we can remember how to do some of this beginning stuff, because this is the stuff that was farthest away from us time-wise. You should all be able to do this, though. How do we change this into degrees?
Put it 180.
Pi is 180.
Divide
180 divided by 10 is 18 times 7. 126 degrees. This is no calculator. Remember, this whole front page, front and back, is no calculator. So you're going to have to be able to take 180 and divide it by something, like 10, and then multiply by whatever the top is. All right, so the answer is 126. That's easy. What about 200 degrees? That's a little harder now. We need to change that into radians. What's our strategy?
pi over 180.
We set up our proportions. So pi over 180 equals what?
That's over 200.
X over 200. Now, does my proportion ever look different than that? No. Set it up, cross multiply. And remember, when you divide, you do have to reduce. So we've got a 0 over a 0. That's easy to cancel out. Then I have 20 over 18, which is 10 pi over 9. Okay. Solomon, I need you to get with the program here, sweet pea. Are you feeling ill? Do you need to go see the nurse? Okay, well, I need you to sit up, no hood. Let's just be ready to Learn. Alright, so I got a 100-degree angle. The radius is 8. And I am finding the arc length. This isn't a hard problem, but it's a 2-step problem, and that will catch some people. Some people will miss this because they'll forget both steps. When someone says find arc length, the first thing that pops into my brain is arc length equals radius times radius. That's how I find arc length. And it's all good. The radius is 8. The problem is what? That angle is a degree measure, and in order to use my formula, it needs to be a radian measure. Didn't I just do that over here? So I'm going to do exactly the same thing. Pi over 180 equals x over 100. And I'm going to figure out what that is, a different x. Oh, maybe I should use a different letter here. Don't you get confused. I'm trying to figure out what this angle is in radians. So I can do that. What is that? 5/9 pi, 5 pi over 9. 5/9 pi. Now that's not the answer though, right? That is not what you put in the answer blank with a circle around it. That is the radian measure. That goes here. So what do we do with that 5 pi over 9? To get the answer, we have to multiply it by 8. So 8 over 1 times 5 pi over 9, 40 pi over 9. We multiply straight across when we multiply fractions. And the unit on that would be feet. If this angle is in degrees, which it's been on both practice tests so far, if that angle is in degrees, you got to change it into radians and then do your arc length. Okay. Let's see. Sine theta is 2/5, and 90 is less than theta is less than 180, and you're finding that. Okay. Well, sine is 2/5. They gave me that, so I can fill that one in right off the bat. And which other one can I fill in right off the bat?
Cosecant
Is the reciprocal. I got that. That's easy. Now, remember I told you that if you were going to draw some random angle, it was always going to be in quadrant 1, unless I told you differently?
Yes.
What does this say to me?
Draw it in quadrant.
Well, draw it between 90 and 180, right? So in regular trigonometry, not the compass, this isn't some ship sailing or something. In regular trigonometry, these are our labels, right? So if I have to draw it between 90 and 180, it's going to be in quadrant 2. That's what 90 to 180 means, between 90 and 180. So the sine is 2/5 opposite over hypotenuse. Here's your angle. So now what do I need to do? Pythagorean theorem, right? Find it for me. Root 21. Be careful though. See that root 21? He's negative. If you got root 29, you forgot that your hypotenuse has to be over by itself. It's 2 squared plus x squared equals 5 squared. So here we go. What's the cosine? Negative root 21 over 5, which makes the secant negative 5 over root 21. What's the tangent? 2 over negative root 21. What do you think? Anybody have a question about one of those? You gotta pay attention to this right here though, right? Because that tells you where to draw the picture, and then you know what to make negative. What if that weren't there? Where would you draw it? Quadrant 1, right? Unless you're told otherwise, you're going to draw in quadrant 1. Okay, all right, couple more here. So we got the cotangent of 300. So we know where 300 is. Remember your labels. So 300 is going to be clear over here in quadrant 4. This is 300. So this is 60. 360 minus 300, that's 60. Do not use these ever in your calculations. This is going to be a root 3, a 1, and a 2. Anything negative?
The root.
Root 3's got to be negative.
No, it makes no opposite. So,
1 over negative root 3,
root 3 over 3.
or negative root 3 over 3 is your final answer. That's easy if you remember all that stuff. Some of you are still struggling with that. All right, B. Oh my, this one's tricky. Negative 420. Well, first of all, what does negative mean? Down and around, right? I'm going to go this way. So if I go this way, this would be negative 90, negative 180, negative 270, and negative 360. Wait a minute though. Negative 420, that means I go all the way around to here, right? That would be 360, but I have to keep going. How many more do I have to keep going? Another 60. So this angle is 60 degrees because all the way around is 360, but I need to go 720, so I have to go an extra 60 past that. So another root 3, 1, and 2, and that root 3 is still negative. It's actually the same triangle as I had over here. What do I want? The sine. What's the sine?
Opposite over hypotenuse.
So negative root 3 over 2. All right, 1 or 2 more problems and we're done for the day. We'll finish this page. I'm not giving you any quadrant information, so where are you going to draw this? Quadrant 1. And you're going to label it so that the sign is 1 over root 2. How big is that angle? That's a 45, so the answer to the problem is simply 45 degrees. Remember, when you see this notation, it means you don't know the angle. The angle is what you're looking for. And you found it. It's 45. Now, the next one, I'm going to tell you to draw it in quadrant 2. So you're drawing this one in quadrant 2. And you're drawing it so that the cosine is negative 1/2. Adjacent over hypotenuse. 1 and 2, what's this side? Root 3? That's not a root 2. That's a 2. So 1, 2, root 3. How big is this angle since it's across from the root 3? 60. Do not put 60 down as the answer, people. The answer is this, which would be 120. How do we get 120? 180 minus 60. All right, I will see you tomorrow.